Still busy with probability. Yesterday I showed you how a two-way contingency table worked, and then I thought about it again because I said to you I'm only going to do the one that I want to show you something else, and you'll see then why I want to show you, because I'm scared you're not going to be able to handle it then. Okay, now the first thing is that you've got to go get the A, B, C, and D, which shouldn't be any problem. Now it's 5 marks either way. Please, when I ask you like that, do tell me here A is, B is, C is, D is. Don't just do as we are going to do now, just to save some time, to go and fill it in over there. Now, can I get A here? But there's 2 variables. But then, can I not get it there? Yes. Because I know that this should add up to a total of 150, so this is 150 to get to 250. Are you with me? Yes. Help me, which other one then? So then B will have to be 450 to add up to 600. Does it have to be alphabetical A, then B, then C? Can I get E first? Yes. Which would be? 750. 750. And then? C. You can get C here, or you can get D there. Or if you've got one of the two, you can get the other one in that column. You're with me that it works both ways. Two-way contingency table. So I'm short? 300? Agrees? And then this, if I look at it here, I'm shorting 400. And if I add it up there, I'm shorting 400 as to work all the ways. Nice 25 marks. Now, this is actually why I'm doing this example. If I just asked you, are these events independent? Now, I haven't even read it, but think about this. What is this whole story about? It's about, oopsie, I forgot to change the Afrikaans to English. It's about being late or on time. And then the other situation is using public transport and not public transport. Sorry about that. Now tell me, if I ask you, are these 2 events independent, what do you think? Is the fact that you are late or on time for school got anything to do with the fact that you're using public transport or not? Yes. We actually think so, eh? Yes. We think that if you're using public transport, you're always going to be late. But that's not the case, and we'll prove it now. According to this data set that has been given to me by looking at these 1,000 people, right? What's happened to them? So now, if I ask you for something being dependent or independent, well, dependency is wrong to use the word. You're independent or not independent. You always have to do what? Check for? Which formula?
The identity.
The identity that says? And on the other side? Few times. But now I haven't put anything there because that's the reason why I'm doing this example. What did you put in there? Because it's about being late or on time and about having used public transport or not. Now usually, if I have to go do it, I'll take the first one at hand. So it's about being late in public transport or late and on time. Late and on time. Public transport and on time. Or these ones are about being late and not using public. These are being on time but not using public transport, and you can use any one of them, but make a choice. So if I said, for instance, let's see if I use late but using public transport, then that has to be about being late and you're about using public transport. Are you with me? So I could have used 4 different scenarios. Late public transport, late not public. On time public transport, on time not. And then you look at the formula. So let's look at left hand side and right hand side. Where will I look at late and public transport? Agree? 150.
Yes.
So that would be probability 150?
Over 1,000.
Over 1,000, which is what? Calculator, please.
Over 20.
Thank you. Then being late. Probability of being late. Yes? 250. doesn't matter if I'm just looking at who's late. I'm not specifying whether they're late or whether they're using public transport or not. The lateness is all about those 250 people that were late out of the 1,000. And the probability that a guy uses public transport, whether he's late or not, is 600 out of the 1,000. And if you take your calculator, I've already done it, I know that they're all the same, so it has to also be 300. So what does that tell you?
They're independent.
That the identity works, and what does that tell you? These events are independent. What events? Being late and using public transport are. So the one doesn't enforce the other one. If you do the one, it doesn't mean that it's going to have to be the other one. So they are independent. Do you see why I wanted to show you this? Because you had to go and figure out how are you going to do the sum, and there were 4 different scenarios. The actual thing I said to you that we're going to do today is tree diagrams, the last thing about probability. Now tree diagrams, I'll show you now how it works, but you could have done this particular sum that I'm doing as an example without a tree diagram. I'll show you now the tree diagram, but let's just go back and say, if ma'am says, if a coin is tossed twice, one time, what is it? Second time, what is it? Then what are the chances of getting 2 heads? How would you have done that sum? You would have said probability of heads and heads. Do you agree? And then what is and entail again? Remember, in a Venn diagram, and is where they intersect. But other times the and means times, right? And or plus. In these, when I don't do Venn diagrams, nothing, then it's always going to be the case. So in other words, actually I'm looking at the probability of having heads and probability of having heads again. Whether it's the first, second, third, whatever time, they're all going to be, what's the probability? Half, right? 1 out of 2. Times 1 out of 2, and the answer would be? Not 1, right? Half times a half's not 1. 1 times 1 and 2 times 2 when you're timing fractions. So that would be a quarter. Now, if I do the tree diagram, the answer had better still be a quarter, because it doesn't matter what technique you use, you've got to get to the correct answer. Because there are various ways. Your middle name is alternative, right? But now if I say, please get me this by using a tree diagram, then you cannot just do this and get full marks. Then I've told you to do the tree diagram. Now how does the tree diagram work? First thing, you start in the middle of the page and you make 2 branches. Why 2 branches? What's the situation?
2 outcomes.
There are 2 outcomes, heads and tails. Then I said I wanted you to do it twice. So this is the first time I flip the coin. It's a heads or tails situation. But the second time, then it depends on whether the first outcome, which you indicate over there, whether the first outcome was heads or whether the first outcome was tails. The second outcome will still have a heads or tails option. And this one will also still have a heads or tails option. That's what a tree diagram is, and that's why I'm going to teach you to always start in the middle. Otherwise you start here at the top, and now where's the tree growing to? There's no space. Okay. Then, that's not enough. So this was my second outcome, indicating what's going to happen. Or first flip and the second flip, whatever the case may be. On the branches, you indicate your probabilities. So what is the probability of having heads and tails? 1 over 2, 1 over 2. And you put your probabilities on the branches. Also, this also always the branches of this one specific situation must add up to 1. Half and a half, 1. Are you with me? Now, whether that was heads or whether that was tails, this will still be half, half. This will still be half, half. Are you with me here? Then the last thing that you must indicate for a tree diagram to be complete is the outcomes must be indicated over here. Now, once they had grade 12s, that they gave, I think, 4 marks for this, which was ridiculous, but when we do what they say. So if the memo says a lot of marks, then, and all you have to do for this mark is to say the outcome is H, H. Heads and heads. This one would be heads, tails. Are you following the branches of the tree? Heads, tails. Now look where I've written it, next to it. So over here it'll be tails, heads, there, next to it. And over here it'll be tails, tails, next to it. Are you with me? Not particular about the semicolons, as long as the outcomes are there. Often people want to already write down the probabilities here. Now that's not the question. You're going to be asked the probabilities over here. So you don't have to go do probability there. Here's a half times a half is a quarter. And there again, half times a half is a quarter. That is true, but you don't have to do it here. So now tell me, if I then say, what is the probability of heads and heads? Then basically you just have to go there and say it was a half times a half. With the branches, you're always going to multiply them. And the answer, truly, still is a quarter. So if I never said anything about you must make a tree diagram, then you could have just done this and you got your 3 marks. But if I ask you for a tree diagram, it'll most probably be a mark or 2 more. How many marks for this? No. No. 2. How hard did you work with these branches? You didn't actually work in the garden, okay, with the trees. So make sure that that adds up to 1, that adds up to 1, that adds up to 1. Every circumstance has to add up to 1. Are you with me? So the question says, 75% of seeds of a certain type. What are we doing here? Biology now. Remember, it's all these stories that they come up with. 75% of the seeds of a certain type of plant yield, in other words, they make white flowers, and 25% yield pink flowers, all the English wording here as well. So you got 75% that whatever you plant will be a white flower, and 25% chance that it will be a pink flower. Now they say 2 seeds are sown. What is the probability that both will be white, one will be white and pink, etc., etc.? Tree diagram, I'm helping you, you're going to finish it at home. What's the outcome? Where do I start? First of all, in the middle, right? Yes. But how many circumstances are here? Because there's white and pink, right? And now this time they gave me a probability in percentages. They said the chances of it being a white flower, so this would be my first seed or plant. Are you with me? First one planted. Which one is first? I don't care. Are you with me? First one can be, well, the chances for white is 75%. So usually if they give it as percentages, I keep it in percentages. There's nothing wrong with saying 3/4, right? And then this would be 25%. So how would the second piece then look? Whether the first one is white or the first one is pink, you still have 2 choices. Still a white and pink, and still a white and pink, and what are the percentages? For the second seed, and then don't forget your outcomes. So it's going to be white, 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 pink, etc. And then you can answer the questions. What is the probability that both of them will be white? So that would be this one. And you're going to time it. Now please, when you do time, you cannot say 75 times 75. It's percentages. So you've got to work with percentages or take it back to 3/4. Don't forget about that. Okay, I'm going to try. Easy.